Hey friends, thanks for joining me, Jim Baroud, to hear a few insights from leaders who represent our innovation ecosystem. Today's chat is with Jiren Parikh, the co-founder and CEO of Ghost Robotics, and Brendan Englot, Associate Professor of Mechanical Engineering at Stevens Institute of Technology. Brendan, let's start with you. Give us a background on who you are and what you do.
Sure. Thanks, Jim. Brendan Englot. I'm an associate professor of mechanical engineering at Stevens Institute of Technology, a private research university located in Hoboken, New Jersey. I've been at Stevens for 7.5 years and started a lab there that we call the Robust Field Autonomy Lab. And the name of our lab kind of captures what we hope to do with our research in robotics, which is achieve robust autonomy. So autonomy and robotics capabilities that work in tough conditions. Some of the conditions that we consider involve outdoors, in air, on the ground, underwater. That's a particular area that we focused on in past years, where communication is challenging, sensing is challenging. And one of the most important aspects is that situational awareness is very challenging. So a lot of our research focuses on how we give those robots improved situational awareness. And a lot of it is achieved through design at the system level, at the algorithm level, and also by incorporating AI and machine learning into our solutions. And that work that we do is kind of inspired by some of the work I've done in my past as well. Before coming to Stevens, I was a research scientist at United Technologies Research Center, which has now recently become Raytheon Technologies Research Center in East Hartford, Connecticut, where I had the opportunity to work on unmanned aircraft, which was very exciting for a couple of years. And prior to that, I did my doctoral studies at MIT, and I got to work on a really fascinating project where we were producing and testing a robot that could perform a fully autonomous ship hull inspection to inspect Navy and Coast Guard vessels for mines, kind of intended to do the job that Navy divers are often tasked with doing. So that whole progression through working on some exciting field robotics projects that had to operate in tough conditions has informed a lot of the work we're doing at Stevens.
Great, thanks for that. So Jiren, go ahead. Talk to us about you and your background and what you do now.
That's great. Thanks, Jim, and pleasure to meet you, Brendan. Jiren Parikh, I'm the CEO of Ghost Robotics. Co-founded it with two PhD candidates at that time in late 2015, Gavin Kenneally and Avik, who were doing their PhD work on actuators for complex electromechanical systems, quadrupeds, ultra-agile robotic arms, and so forth. So they had come up with a brand new concept for building a quadruped or any other type of legged robot, using different technology, different IP versus some of the leaders in the market like Boston Dynamics. And it was the three of us in my so-called basement. That was late 2015. We're at about 30, 31 people now. We're hiring as fast as we can. Obviously, hiring is a little bit more challenging right now. We are focused on government markets. About 90% of our business is with US and allied government customers. We have about 25 active projects going on worldwide today. About 50% are in the US, the other 50% are with our allied customers. And another 10% of our business is with large enterprises. So the enterprise business is coming for legged robots. We'll talk certainly about the applications and use cases here, but we have a feeling like 3 years ago we entered the DoD, Homeland Security, and Intel space. We have that same feeling today entering the enterprise space. So we think there's some great growth opportunities there, and our partners include folks like Verizon, AT&T, Carlson Software, Ares Security, so larger mid-market enterprise companies that are building solutions for inspection or security. A little bit about myself. Prior to this, I ran a company in Princeton, New Jersey, where I got to meet James and many other folks from NJTC at that point in time. Snap One was a company I was restructuring, and we were able to grow that company from, take it down to 5 people and all the way up to 120. And then eventually we had an exit on that business to Synchronos. My prior experience, I've spent most of my life in sales, product management, marketing functions, most of it in international markets. many growth stage and startup companies. And so it's been a terrific journey, but this is my first time working with hardware. And it's extremely challenging, probably the most challenging opportunity I've had to work on in my career.
Thanks for that, Jiren. So let's get right into it. A lot going on in the robotics space. A lot of it has been affected by the pandemic and accelerated. But I really want to hear from you folks. What is the state of the industry now, and where has it come? Right, you've both been in this sector for a few years at least, and so you've seen the changes and the growth. So, Brendan, let's start from a macro perspective, from your perspective, someone who's at a university.
Sure. Yeah. I mean, although, perhaps admittedly, the role of robotics technology in addressing the COVID-19 pandemic may have been a little underwhelming in terms of our preparedness to have solutions to immediately roll out to address it. I would say the state of the industry as a whole is, very exciting, very promising, and there's tons of continuing growth across many, many different sectors of robotics. I think one of the most exciting things happening now is the fact that there are so many consumer robotics technologies that are becoming available, that are being widely used, so that everyone is becoming more familiar with robotics, not just specific users in industry or in government or in health and medicine. So that aspect of it is very exciting to me, and motivates a lot of the solutions that we're developing. That we're now, we know that some of the algorithms we're developing aren't just going to be used by specially trained end users, but we need to make robotics accessible and understandable to everyone. So,
got it. And how has it changed? Drastically, nationally or globally? Are there certain dynamics that you're seeing that we should know about?
Well, I guess that aspect of the growth of consumer robotics that are available to consumers is the part that's the most exciting, considering I got involved in the field, maybe 15 years ago, when much of these, the ideas that you're seeing come to fruition today in autonomous vehicles, autopilots for self-driving cars, unmanned aircraft, consumer robotics that can work in your home. Many of those were kind of blue sky ideas, and where everyone was waiting to see what would happen if the field was going to grow to the point that there would be an explosion in, consumer use of robotics technology. So I guess seeing it cross that barrier has been very exciting from my standpoint, and it's one of the most interesting new trends, as within maybe the past 5 to 10 years that have occurred within robotics.
Got it, Jiren.
Yeah, I think timing is everything, right? Legged robots, for example, got Avik and Gavin did their PhD work under Daniel Kodashek, and he developed the first quadruped, independently battery operated quadruped, Boston Dynamics' first robot called the Rex. It's a little shoebox sized robot. It's quite interesting. 15 years later, to see our quadruped, for example, this Vision 60, we'll see a video of it in a moment, to do, 8 miles on a single charge, on a battery charge, have a lightweight robot that can move fast, right? 2.5 to 3 meters a second, completely durable, waterproof. From that day, 15 years later, it's amazing to see this product. But you can imagine the amount of money that's gone into kind of building the core research. Companies like Antibiotics, Boston Dynamics, Agility Robotics, each one has their own strategy, and actuation and design of these platforms, how they're controlled from the enterprise, software component, what sensors they're using. But that journey from an idea to actual fruition and commercial use, long time, right? The cycles here are a little bit less than, I would say, battery technology, right? Or endurance technology. What the challenge we see now is who's going to buy these robots and what are they going to pay? And so with the timing, you've got, the cost and application development issues. So applications with legged robots, I think most people's sense was they're good for videos. And that's really about it. You can see a lot of these companies have great videos of robots that walk and do terrific, have terrific behaviors in front of a camera, but in a controlled environment. When you get in an uncontrolled environment, that's where the fun begins. And so that was one of our strategies when I met Gavin and Avik was, hey, listen, do you really want to compete against, at that time it was Google that owned Boston Dynamics, says, do you really want to compete with these guys? Because they can outlast you, 10 times over. And I don't really see any applications for these robots. But it was pretty clear that the military had some fundamental constraints in the field with casualties and loss of life that could be mitigated with these robots. So we thought the best thing to do was to start marketing these into those government markets first, like a lot of technology, right? Aerospace technology, electronics, the internet, you name it, right? Go into the military DoD space. There's a lot of money to fund those mistakes. So you can get rid of that timing calculation, get to a use case. And now, as I mentioned earlier, now we have a robust product that's in the field. It's ready, or we call TRL9. Brendan probably knows that all too well. Getting from 8 to 9 is like a pain in the butt. And so now you have this TRL9 product. What can you do in the enterprise? The second challenge I talked about was the cost variable. That's still a challenge, right? And we need to work on that. Higher volumes, lower cost computational systems, sensing platforms. So I think that's coming. And then, the holy grail, right? Can you have a legged robot walking around in your home, as your mobile IoT security and, family watchdog? That's coming, but it's probably another decade away is my guess. Can we get those price points down? And we may not be the winners there. It might be some Asian countries that are very good at those low cost platforms. But at the highly engineered side of it, for defense or mission critical industrial enterprises, I think the U.S. and Western markets have an opportunity to kind of own that space.
Got it. So what about globally, Jiren? How are you seeing things? Are other countries sort of ahead of the pack, or how do these fit?
Yeah, I would say so. Southeast Asia is, fundamentally, just generally talking, enterprise government applications. We see a lot of uptake in Southeast Asian markets, some North Asian opportunities. Europe, I think many of these countries and markets are more used to automation of tasks. They either lack capable resources to do something or the expense of it. I don't think that's not the case here in the US. I just think hopping on this automation bandwagon may be a little bit slower. Now, if you separate the military market, the government market, a lot of allies are a lot more fast moving. Why? Simply because the countries are physically smaller. The budgets are smaller. They're a lot easier to wield and manage versus a US Department of Defense budget. It's really large, right? So a lot of stakeholders, a lot of politics that are involved, and you have to compete for money against some very, very big contractors and old ways of doing things. So in the military market, we will actually see adoption in other allied countries accelerate maybe 12 to 24 months ahead of the US.
Oh, wow. And what would some of those countries be? Just curious.
Singapore is a great one, right? Australia, my experience with Australia, for example, or some of the European countries is the check comes faster, right? It's super easy. There's a lot less paperwork, bureaucracy involved. And again, I think that's just physically the size of the country, how they're run. They may be, countries or markets that have newer bureaucracies, right? A lot less, a lot less paperwork involved. The U.S. government is a big, big customer, right? And there's so many segments and subsegments, and it can be challenging dealing with. By the way, somebody may want to buy your robot, even if they have the cash. Is there a contract vehicle to give you the money? We have to deal with unique challenges. A lot of foreign markets, we'll just get a wire transfer. Thank you very much, directly from the Department of Defense or their embassy. Please ship us the robots, right? And they'll prepay it. So it's quite an interesting dichotomy there.
That is interesting. Now, what about, speaking of money and funding, the infrastructure bill, the additional monies that will be coming from the federal government, is that affecting you? And is that affecting you, Brendan, as far as research?
Well, it's exciting to see new legislation that prioritizes infrastructure. I'd say one of the most exciting roles that robotics can play in that is helping in the inspection and maintenance, potentially in repair of infrastructure as well. putting robotics technology in hard to reach places. And I think a lot about this underwater in particular, where it is really hard to put eyes underwater at the looking at the infrastructure that needs the most attention. So in burgeoning efforts like the development of more offshore wind infrastructure, repair of existing infrastructure, I think robotics can play a huge role in that. And perhaps this new legislation is going to be a driver of more robotics technology to help solve problems in that area.
Right. What about you, Jiren? How are you saying? You obviously the defense budgets are pretty full, pretty robust. Are you seeing any additional possibilities through other areas of the government?
Yeah, but by the way, I would make that comment. A lot of money in that pot, but also a lot of people with their hands out. And a lot of smart players like big defense contractors that are really good at it, right? With lobbying efforts and so forth. So small companies, if we're very fortunate, right? We have a legged robot. So everybody wants one, which is great. Our numbers and scaling it. In fact, as I've talked to a couple magazine editors, they believe we've shipped by far the most robots this year in legs versus any of the other competitors in the market, including Boston Dynamics. So we are the number one in kind of government and allied markets, but you have to fight for it. In terms of the infrastructure bill, we think there's opportunities to potentially do more manufacturing in our home country. All of our electronics and components are US and allied made. But if you can bring everything here, I think that infrastructure bill will help us potentially for manufacturing critical components here that, and you'd be shocked, even if they're in an allied market, they're at risk, right? From a logistics and supply chain perspective. So we think that's going to help there too. I think Brendan hit the nail on the head. As an afterthought, as they're spending this money and building things, they're going to need to inspect and manage it. And maybe robotics has a really strong play there. So that's certainly a potential opportunity.
Well, let's talk about the manufacture of robots, right? We all hear about the supply chain issues. What percentage of your robots are built, outside the US, or what components, and what's the optimal situation we might want to be in 2 or 3 years?
Yeah, so in our case, our entire robot is custom. All the electronics, compute, bus board. I mean, we go as far, motor controllers, even encoders, everything is custom. First of all, we have to lock it down. It's got to be secure. Another reason is legged robots aren't efficient. Typical legged robots, even the marketing leader, Boston Dynamics, those things run 40 minutes. I've seen them in the field. That's about much as they run. For us to get our robot to run 3.5, 4 hours continuous walk time, we have to, it's highly engineered, right? The entire robot runs on a 1-watt microprocessor, main bus board. So all of that is under our control. The electronics packages, they're all made here. Custom cabling, wiring, everything. All the design is all here. What we do source from external markets are ICs, radios, sensors, but none of it is from a non-allied marketplace. It's all close allies, right? Europe, Israel, Canada, the Five Eyes typically. Metal, we will get cheapest wherever we can get. Funny enough, the DoD is, we don't want to pay extra money for the robot if you can get machined metal from Mexico. I don't think they have a requirement to make that stuff here. So our challenge on the supply chain is really at the sub-component level, ICs and other bits and pieces that go on these electronics boards. But we're a little bit more like a Tesla versus a General Motors. If you saw their quarterly earnings, General Motors, there's a boatload of cars they didn't ship because they had supply chain issues. Tesla or SpaceX, on the other hand, if they can't find an IC for an electronics board, they'll just reprogram in a new one over 2 weeks, which is what we do. So we don't actually have a supply chain issue here. We will redesign in new components into our electronics, depending on what's available. And we can typically do that in a few weeks' time. So our supply chain issues haven't been as problematic. And especially since we make everything ourselves, outside of an NVIDIA application board and some sensors from companies like Intel, everything else has been pretty straightforward.
That's good to hear. But is there an optimal, in 2 or 3 years, would you like to be at a better place as far as insourcing things more from is that even realistic?
I think making it in the U.S. makes it easier, right? And I think we recognized here after this pandemic, and some of the kind of political constraints we've had right now with kind of adversarial countries like China, right? Our frenemies. It just makes sense, right? I think we're now on a new path where, at least over the next decade, I see everybody's going to be focusing on buying or trying to manage sourcing directly in their home country for a number of reasons, right? And so I think that's good for us. The challenge is our cost structure here will negatively impact on how these technologies scale if we're making them here. Now, if you've got a consumer product, you can make it in Asia, that's perfectly fine. But for a defense or a mission critical industrial enterprise, that's tricky.
Right. So what about the funding? Going forward, you've seen it, Jiren, from an entrepreneurial perspective. I believe you're venture backed, and Brendan, you see funding in general mostly from government. How has funding sort of changed over the years?
Yeah, that's a great question. There has been a lot of investment and prioritization of robotics research on the government side. I would say it's a great time to be a researcher in this sector because of how many different opportunities there are. And one reason I think is because robotics technology is so cross-cutting, is that every sector of the government focused on important issues understands that robotics is an important tool that will help them advance their goals. So, whether it's the Department of Energy that's interested in robotics technology for inspecting energy infrastructure potentially, or NOAA, interested in robotics technology as a data gathering tool to support their science mission and to support better prediction and forecasting. Or in my case, a project we recently had funded was actually from the USDA, interested in robotics technology for agriculture. It's pretty much across the board. There's really an important strategic investment being made in robotics research. So things are very good from that side of things.
Good. Jiren, what about from the private sector?
Yeah, so I would second Brendan on the government side, right? There's a lot of funding for robotics automation, DoD, Department of Energy. There's just all sorts of opportunities. From the private sector, there's boatloads of cash going into venture-backed companies. Obviously, we had the larger bubble early on with companies like Rethink Robotics and all the little consumer, Muppets that would sit on your desk and talk to you. And those are all dead, right? There's already billions of dollars gone to waste. But now there's a new crop, right? And this happens, right, in every tech segment, right? You've got those early adopters, a lot of crashes, a few wins. Now you're going to have a lot more wins. People are not focused on a robot, right? They're not focused on, hey, make me a new drone or maybe a ground platform. Give me a solution, right? That's what customers are buying, solutions, right? That's what we should be developing. In our case, we have lots of people that want to throw money at us. So raising money is not an issue. We haven't raised much here. We've raised less than $8 million over the last 5 years. And we've just raised 4.5 of that 8 million over the summer. So we're in a good business. Our robots are expensive. Each one is like 150,000. And you got about maintenance and warranty contracts on it. Gross profit margins are good. So we've been able to scale this business by selling these prototypes and getting to the stage where we are now for a commercial ready robot. So we feel fairly comfortable getting money, both equity capital, debt capital. But you can also sense that there's potentially a bubble building as well. You've seen a lot of SPACs, companies like Sarcos now as part of a SPAC. I think the valuation is like 1.3, 1.4 billion. Don't quote me exactly on that. I think they have less revenue than we do, which is surprising. So, we have some strategic options too, is how do we raise additional capital for business growth and operations and for our shareholders too.
That's great. That's great to hear, Jiren. Now, what about just if we can double click on that, as far as, are your investors local or regional, or are they from the West Coast?
Yeah, in our case, we have our lead investors, In-Q-Tel, the investment arm for a number of the U.S. intel agencies. We also have a lot of early stage. Surprisingly enough, we're generating substantial revenue now, but we've not done more than our seed stage, right? We're not even to a Series A yet. So we've got some tier one, seed stage investors as well. We haven't even pulled the trigger on a Series A yet. So we're surviving on, through cash through operations and growing the business. We may look for additional funding next year. Hopefully the market will continue to be robust.
Right. That's great to hear. And so where do you see your company, at revenues in 5 years or market value in 5 years? Is that a fair question?
I think revenue. So bulk of our business is government, right? Department of Defense, Homeland Security, Intel. How that works is, you prototype with them and you pilot with them, and then what they have called program of record, right? They can do program purchases. So we have two types of customers that don't care about program purchases, special operations teams worldwide. We deal with the soft community and every one of our in the U.S. and allied markets. They don't need a program of record to buy anything, whatever they need. So we have robots that are being used in the field today, and they'll continue to buy, and that's going to grow. Probably in 24 months, you're going to hit some large programs of record. And, give you an example, Endeavor Robotics had one program of record with the Army. They'd split with Kinetic, and they were bought for $375 million by FLIR. And they were spun out of iRobot for $30 million, I believe, from Arlington Capital. So they went from $30 million. 4 years later, they sold it for $375 million, program of record. We'll probably have a half a dozen programs of record in 36 months, US and worldwide. This business is highly scalable. It's potentially, north of 150 million in revenue in 5 years from now, tied to these large scale projects that we're working on today.
That's fantastic to hear. That's really exciting. So what about you, Brendan, as far as what's next at Stevens? I know you have a robust program anyway, historically, but how do you see your program growing?
Yeah, there have been some big investments and commitments made by the university to AI and robotics. And I think we see them both as being very critically intertwined. And AI has been responsible for some of the biggest exciting new achievements that we've seen in robotics. So we're trying to respond to that through the way that we're steering our research activities, the way that we're steering our educational activities as well at Stevens. One exciting thing that rolled out very recently was that we now have a Master of Engineering in Robotics degree. So you can now earn a master's in robotics and be well prepared to go out and meet the needs of the industry today. And we also have an AI Institute, which includes robotics in its portfolio. And there's been a lot of new faculty who have been joining us, doing a lot of very exciting research. These days, our research portfolio at Stevens spans not just my own area of autonomous vehicles, but we have faculty working in medical robotics, rehabilitative robotics, grasping and manipulation technologies. And we now even have our own indoor drone flying space at Stevens that has been built and completed within the last couple of years. So there's been a lot of exciting stuff going on.
Oh, that's great. I can't wait to see that drone space. So Jiren, you are, and Brendan, you're in Hoboken. Stevens is in Hoboken. Assume you're there as well. Jiren, you're Zooming from Philly. Is that right?
Yeah, we're downtown Philadelphia. We're at, our offices are at the Penn Center in south part of the city. In a few months, we're actually moving to the Navy Yard as we expand here. So yeah, we're going to be keeping our primary operations in downtown Philadelphia.
That's great. So you collaborate with UPenn. Tell us about how Penn is, how their operations are as far as in robotics, and can you speak to that? I don't know how closely you collaborate.
Yeah, we're separate from Penn outside of hiring some folks from there. So we don't work with the University of Pennsylvania. We have no tie to them. Gavin and Avik were obviously doing their PhD work there. They completed it, and Avik had a short stint to do at Harvard on a postdoc after 2015, but it's really just been focused on Ghost. We just happen to have our offices here at the Penn Innovation Center, but we don't work specifically with them or any other university. We typically don't disclose most of the work that we've been doing since their postdoc work.
Right, but do they have a robust program there at Penn?
Well, I mean, Vijay Kumar has done an incredible job, the dean of the engineering school. I mean, he's obviously a superstar. He's done a lot of early work on small lightweight drones with DARPA. They have a great reputation. A lot of great companies have spun out of their Exit Technologies. They've spun out of there doing incredible work with autonomous aerial platforms. They have, in fact, seeded, some of our top leaders, right? Our engineering leaders and controls and behaviors and electronics and mechanical are all from Penn. So they're a great ground, opportunity to hire. But we're also working, to hire folks from all the local universities here. And hiring is a challenge right now, right? There's some inflationary pressures. People may or may not want to leave unless the packages are supreme. So even a legged robot can't get them to leave their existing jobs. So we're working through those challenges, and I'm sure Brendan has probably seen similar types of behaviors for other companies as well for hiring.
Sure. And why don't we segue into that talent? Where are we? Where are the opportunities and challenges? Are there enough folks coming out of college that have the degrees and the expertise and the focus? Brendan, why don't you take that?
Sure. Yeah. Well, it's an exciting time to get involved in robotics, and there certainly is a lot of demand, from students who want to tailor their education toward those opportunities. A lot of students are, reaching out about master's and doctoral programs in robotics, opportunities to get involved in research. One of the challenges, I guess, recently that was largely brought on by the COVID-19 pandemic and our reactions to it was cutting off a lot of the great international talent that so very much wants to, get their higher education in the United States, become part of the U.S. technology workforce. Many of them were unable to apply or come to American university programs. Some have stuck it out and did a year or two online and are now starting to get visas again. But there has definitely been a shift, and I think some of the countries that used to be, huge constituents in that area, many talented students who wanted to come from Asia to pursue higher education in the U.S. Some of them have begun to look elsewhere because of the challenges of getting a visa to come be a student here. So with that, however, there is of course many opportunities, and many domestic students are aware of that and are pursuing higher education and trying to address those opportunities and join the workforce and contribute to robotics. So there have been some pluses and minuses in that end, but we do have a lot of healthy interest from domestic students as well. And definitely our programs and research in robotics is growing because of that.
That's good to hear. What about you, Jiren? Obviously, you mentioned currently getting experienced folks is a challenge, but are you seeing a bigger pipeline going forward?
Yeah, well, so we have a lot of applicants. We get applicants daily. I think the challenge is finding those that are qualified for this type of highly engineered, integrated platform. So now we're in the commercial ready products. These things are have to have substantial mean time before failure hours and capabilities and durability and all these environments. They don't exist, right? None of this stuff exists. So there's R mixed with the D. And that's a challenge finding those level of people, enough of them here in the Philadelphia metro area. So there's a huge number of students that are coming up, and we're hiring certainly, finding application developers, not an issue. Finding, highly qualified folks for this type of highly engineered product. They're also typically at companies like Raytheon, Northrop Grumman, other companies that make highly engineered aerospace and defense tech. And so we also have to compensate at that range now, right? And so that creates a challenge. And Of course, you got to work with your investors. You got to raise more money. You got to modify your compensation and programs to do it. You got to do it, right? It's as simple as that. So I think there's a little bit of pain for smaller companies, but over the long term, it's no different than any other era or decade, right? For tech, you saw this boom, at the .com period. Salaries, were a bit crazy at that time. I recall. After the financial crisis, right, it was another boom. And so I think you're just going to see it. And it really depends on what segment you're in. Robotics and automation and AI, autonomy is really compelling. Also, a lot of companies that are hiring there, right? If you want to hire a perception engineer, the top guys are they're at Google or they're at other automotive companies, and you got to bring them to Philadelphia. And so, we've got to work with those challenges. And by the way, Brendan, if you've got talent up at Stevens, we're hiring as fast as we can. So send them over.
And speaking of that, Jiren, everyone's talking about work from home. Is that possible at a company like yours, or are you, everyone's in the office, in the lab?
Yeah, that's challenging for us, right? So we got our closed down shop order, March 2020, right? From Governor Wolf. 24 hours later, that the next day we filed for petition for an exemption. So we've had a national security exemption, and so we've been in the office since shutdown. A little bit unnerving, but it's really critical, right? What we're doing physically with robots, and we spent a lot of money, right, putting in 0.1 micron HEPA filters throughout every room in our facility. Early on, we had ordered over just under 10,000 masks and KN95 masks in February, March, and April. I'm from India originally, and so bad things happen with disease. So it was a no-brainer connection for me. So we just took those precautions, and we just try to operate in a highly controlled environment. And we had no choice but to do it. And thank God. We didn't have a COVID outbreak until just last month, even with folks vaccinated in our assembly and repair shop with 3 people. But we've taken precautions, and we also have a mandate, right? Nobody can work here without a vaccine, and that's been important too.
Right. Well, for those of folks who don't know what it looks like, your robots, your dogs, why don't you pull that up and show them? I love seeing them in action. And think everyone else will as well.
Yeah, so I'll skip through this video. It's 6 minutes long, but that robot comes apart in 15 minutes. And that's really a work of art and engineering for something that's got a lot of complex wiring and actuated systems in there. This is our robot showing our core IP, where we're using the motors as sensors. So typical legged robots use proprioceptive sensing, force sensors in the legs or at the output of the motors. We don't use any of that. We use a very highly transparent BLDC motor, and we can feel the environment there at 2,000 instructions per second, any force on the robot. So the robot not only looks good on video, but when you put it in the field, it operates through swamps, just absolutely mind-boggling terrain. And so that's what's very unique about our robot against the Boston Dynamics, which looks good on video, but constantly fails in the field. And we see this time and time again because they rely on proprioceptive visual sensing and force sensing through the legs, where in our case, our robot is like life. You push it like a dog. If it's a dog's next to you, it's going to push back and stay stable. And so maybe I'll bring up some quick videos. So the robot here, for example, doesn't know that there's a stairwell there. And I'm going to try to bring that up for you real quick right here. So the robot doesn't even know that the stairs are there. It just happens to be climbing it, completely blind. And it's really, really impressive technology. It's taken years to perfect. We are using sensors today to make it elegant, walk around a car or walk upstairs elegantly. But if it fails, it always goes back to its blind mode capability to stay stable, which is fundamentally why they're using a legged robot, right? They're using a legged robot to operate over all sorts of crazy unstructured terrain. And the robot should get from point A to point B to do its mission And the operator shouldn't have to worry about what the substrate, what the angle of ascent is, if it's walking through, an old riverbed here. It shouldn't care. And so it's really fun and exciting to build these things. And you can see them with different payloads here, chem biological sensing payloads. This robot has sensors there that cost hundreds of thousands of dollars on top of our robot for special forces. Here's a small robot that we built that we'll commercialize here shortly for different applications. And so we're going to be building a whole portfolio of different shapes and sizes of quadrupeds. This is a very compelling video in really loose substrate. And the robot doesn't know anything about its environment. It's just getting a velocity command to go straight. And it's going to do whatever it needs to do to get to its objective. It's really just amazing. And you can see these as very valuable for combat operations, security operations, all sorts of different use cases across inspection and security for enterprise as well.
That is amazing. And you used to have one that used to climb fences. I think I remember that one.
Yeah, if you go to our About page, that was the first robots Gavin and Avik built. They're the Minotaur robot. And, we used to sell that robot for $9,000, right? All day long to universities, and customers like Google and NVIDIA used to buy them to do research and stuff. 5 years later, this is what we built, this amazingly portfolio of durable, mission-ready robots for war fighters and other, operators in the field that need the protection or need the capabilities of something like this.
That is fascinating. Really, congratulations, Jiren. That is amazing. And now, who is so you mentioned Boston Dynamics. They get all the love or the publicity. Are they your main competitor in general? And is there a foreign competitor that we should know about?
Yeah, that's really it, right? We're the only US-legged robot manufacturer left that's US owned, right? So, and Boston Dynamics is owned by Hyundai now. They went to SoftBank and Hyundai. They have a nice product. We don't think it compares to ours. We've seen it in the field. Now, I don't think there's anybody else out there that makes anything close to what we built. Yeah,
that's amazing.
And we own north of 90% of U.S. and allied government market purchases, which is the largest market today.
Wow, that is amazing. That really is. So you can move this off the screen. So when my kids ask for a dog, I always say, I'm going to get you a robot dog. How far away am I from that, delivering on that promise, which obviously deflates their excitement?
Well, I mean, Christmas is right around the corner. And if you have a lot of money, I can get you a robot by Christmas. So you can get it to them now. My guess is they're probably a decade away, right? So, you've seen some Chinese models, these smaller robots very similar to our Spirit 40 robot. They're selling them for like $10,000. They'll be cheaper. Now, again, you get what you pay for, right? These robots work for a certain amount of time before they overheat. And, they're not made for, throwing down stairways or off, our robots are made to parachute off planes and that type of stuff. So you're going to get what you pay for, but you can see that progression. Is it unreasonable that you're going to be able to buy a $2,000, $3,000 robot a decade from now that your kids can have fun with? I think there's probably a good chance that it will happen.
Okay.
Likely not from Ghost, but there might be some high volume kind of consumer product manufacturing company that'll come up with something.
Got it.
Yeah, that's been a remarkable trend across a lot of different sectors of robotics. In my domain, you used to need on the order of $50,000 to buy an underwater robot that you could do anything meaningful with. And now driven largely by hobbyists too, who really want to get their hands on this technology and tinker with it. We can buy something for a few $1,000s, 1/10 the price of what it would have cost maybe 10 years ago.
Yeah, it's amazing. Yeah, and by the way, sensors too, right? Some of these sensors used to cost like $100,000, $150,000. Now you can buy them for $5,000. Why? Companies like FLIR have done a great job scaling the technology, scaling it down, taking the cost out of it. The volumes have gone up. Everybody's using a sensor right now. Everybody's using the word sensor. My God, I never used that before. I used to call it a camera. Now everybody's using the fancy word sensor, but you could buy these FLIR sensors at Home Depot, right? You put them on your phone to do a thermal reading on your pipes. It's really amazing how that has evolved. Now imagine cars have dozens and dozens of sensors, millimeter wave, sonar, radar, thermal, LiDAR. The prices are going to just drop, enormously on a year-over-year basis.
Right. This is really this is really fascinating stuff. There's a couple of questions. Before we get to them, what's one thing we should know about the future of robotics? Brendan?
So relevant to what we were just discussing, I think it's very tempting to think that robotics are subject only to Moore's law, that there is going to be this amazing explosive doubling of their power that we can fit into the same size package year upon year upon year, but they're subject to Newton's laws as well. And so I think similar to what we've seen with the development of automotive and aircraft technologies, the physical capabilities that you're seeing in that video are really challenging to achieve. They've taken a lot of time and effort to develop, and their physical capabilities are probably going to continue to evolve slowly, even if their sensing and computing capabilities have been exploding.
Yeah, well said, Brendan. That is a challenge, right? For us, for example, you want that robot to go 100 miles. We can't do it. We have to rely on endurance technology, right? Fuel cells, battery technology. That moves at a completely different cycle, right? That's years over years before there's substantial changes. That's the challenge for us. Motors are not made to go back and forth, right? In this case, we have to have a motor that spins in a circle, right? That allows it to cool itself, right? Basic physics. And so having larger motors, building larger robots to carry heavier payloads in terms of legs doesn't scale from a physics perspective. That motor technology doesn't exist. Sensors can't read data fast enough, have this running through the wild to use perception. We could barely get a car to work on a road, which is kind of a controlled environment. Talk about that robot while it's climbing up, unstructured terrain in a mountainous region. Some really challenging physics issues here that, as Brendan noted, we're just going to have to wait to get resolved.
Got it. Robotics can be used for good or evil. Can you talk about the ethics around robotics? Brendan, you want to take that first?
Sure. Yeah, no, it's a very important point, and I think it's something we need to be aware of as researchers and practitioners and producers of this technology. That, like many tools, similarly to how you could use a hammer to build a house or to tear one down, we need to do our part to frame the conversation around responsible, ethical uses of the technology. I think to a large degree, our community has succeeded in doing that. The government that has, sponsored key applications where we really have a compelling need for the technology has succeeded in doing that. I guess the message I would convey about that is, I think one of the most important and ethical uses of the technology that has succeeded to date is its use for these so-called dull, dirty, and dangerous tasks that take people out of harm's way. And I think that's one of the most compelling applications for robotics. And, we need to continue to be aware of that in framing the public conversation and promoting the use of robotics for good.
Yeah, it's a question of science. It's science and human values, right? Where's that intersection, or where do you stop and start? What's more important, right? Take, for example, what we do. We support our government customers, our warfighters, special operations team members, counterterrorism. We're working with teams that are handling weapons of mass destruction issues, right? Some serious stuff. And in all of these cases, they can use any payload they want: sensors, radios, non-lethal, even weapon systems, right? That's what the Department of Defense does. That's what we do. We build a robot that the warfighter can put any payload, including sniper packages, target designators, cameras, right? So take example, we released some sniper packages at the big Army AUSA show in October. And there was a bit of an uproar. The vast majority of feedback was very positive, right? And a lot of people that are in the business, they walked by the booth and said, I'm not interested in that. I'm interested in the CBRN thing. It's just a matter of fact. Now, people got crazy because we had a legged robot with a sniper kit that's used by special operations team members that are in very stressful situations. And in my advice to people that thought that was offensive, I said, hey, listen, I don't have a problem. You don't want that robot taking that hit on an enemy combatant that could do some great damage to our national security, then send your son and daughter to take the place of that robot. That's my message to them. If you take a look at the US government and our allies, they're ultra conservative about using any type of weapon system on a robot. Why? That's the rules of engagement. And the US is just ultra cautious. Everything is man in the middle, man controlled. It really is a remote walking tripod. Now think 20 years from now. And I think Brendan's point was we have to be cognizant of everything today. Otherwise things can run amok. And that's where researchers come in. That's where companies, the private, even the government comes in and puts the rules of engagement down. So we have to have these really strong rules of engagement about autonomous and AI systems on weapons. And it's not just us, right? Everything is going autonomous, tanks, planes, you name it. So, Ghost is really a tiny piece of it, but we're all cognizant of it. We have to be careful about who we sell these robots to. We have to put in fail safes. It's amazing. By the time you even see a weapon on even a legged robot like ours, it'll be years away. And you'll never see it because it'll really be special teams or special forces that are using it. Now, we should not have our head in the sand. If you take a look at China, Turkey, even Pakistan and some of these other countries, we should be very concerned, right? Because they're using inexpensive drones that they're buying in retail, strapping them with explosives or other ordnance, kinetic applications. And, we have to be ready, right? And I think that's a lesson on all technologies that are dual use.
No, that's a great way to end. This has been really fascinating. And we're going to have to do one of these a year from now and, just keep updating us on the changes, because the work both you were doing is really important. And, just thinking about how many lives, your robots have saved, Jiren. I mean, that's impressive.
Even basic things like CBRN sensing, EOD, right? Bomb techs. Our robots are a lot better than a wheeled or tracked device, which is the state of the art today, and being replaced by legs. It's a huge impact for the good. I think just like everything, as Brendan noted, we just have to be cognizant of it and have more human value discussions as part of any technology that we're introducing in the market.
Exactly. Well, on that note, I want to thank both of you. Brendan, thank you, Jiren, and keep up the good work. Thanks for joining us. I hope you enjoyed the show. Please like it, leave a review, and subscribe. See you soon.